In this lecture, we are going to learn about a very famous sorting algorithm known as merge sort. So this is based on the paradigm of divide and conquer. Okay, so this is a very famous way of solving problems, that is divide and conquer. So the main idea is that if the problem is very big and difficult, so just break the problem into some smaller sub problems which can be solved much easily, and then we combine the result. Okay, so let's see how we do it for sorting. So as we discussed, so it's based on divide and conquer strategy. So divide, here what we do, we divide the array into two sub arrays, one on the left and one on the right. Then we recursively solve the smaller arrays, and when those sub arrays, the left and the right sub arrays, they are sorted, then we merge these two sorted arrays together. Okay, so that's the idea. And how we write the code is that we have an array A 1 to n elements are there. We have the P is the index of the leftmost index element, and R is the index of the rightmost element. And till P is less than R, so till we have at least one element in the array, so what we do, now this is the part for divide. Okay, so what we do, we find the middle element, that is P plus R by 2. So we get the middle index of the middle element, we take the floor of P plus R by 2. Then what we do, we call merge sort recursively on A P till Q and then A Q plus 1 to R. So if this is an array, so this is the first index, this is the last index, we get the middle index P plus R by 2, and then we sort this array, so P to Q and then Q plus 1 to R. Okay, and then what we do, now we have some sorted array here and we have sorted array on the right hand side, and then we merge these two arrays. Okay, that's very simple and nice. Okay, and to sort the entire array, so what we call merge sort A, 1 is the left index and n is the right index. Okay, so let's see. But the thing is, how do we merge two sorted arrays? So we saw that, okay, we sort this part of the array, we sorted this part of the array, and then we have to combine the left and the right sub arrays. But the thing is, the good thing is that these two sub arrays that we need to merge, so we need to merge two sub arrays as conquer part, and the good thing is that these two sub arrays are sorted, so we have to just merge two sorted arrays. So that seems to be much easier than sorting to merging to non-sorted arrays. Okay, so merge, so for that we need an array, we need the first array and the second array, and how we give in these three arguments. So P to Q is the first array and Q plus 1 to R is the second array. Okay, so L1 is the size of the left array, which is Q minus P plus 1. So if we have elements like 2, 3, 4, 5, this is L, this is R, the number of elements is 4, which is 1, 2, 3, 4. So this is 1, this is 4, so 4 minus 1 is 3 plus 1, so there are 4 elements. So now L2 is R minus Q, because now we have R minus Q elements on the right. So we created arrays L 1 2 L1 plus 1, these many elements on the left, and R also has 1 2 L2 plus 1 elements. Okay, so now what we do, we copy from array A into L1. So we copy the left part. Okay, so we copy the left part in L array, and we copy the right part of the array in R. Okay, so this is the way. So we copy the left part in L and we copy the right part in R. So now, so I is 1 2 I L1 and we copy here. Next, what happens, in the last index we put infinity. Okay, so now let's see. So we want to combine. So how do we combine? So for combining, what we do is, we have two indices, I is 1, j is 1, and then what we do, we start for k is equal to p, k is less than r. So these are the two left and right indices of the array A. So if now we have two sorted arrays L and R. Okay, so this is L, this is R, and we have an array A where I want to merge these two sorted arrays. So if Li is less than Rj, okay, so I is here, j is here. If Li is less than Rj, it means this one is smaller, so I copy this L1 here, and then I is increased to this place. Okay, I is I plus 1. Next, again we compare these two, and whichever is larger, so for that one we increment the index there. So we will take this with one example. Okay, so we will take one example to look at this. Okay, so now what happened, sorry for this delay, but okay, let's see. So we have an array. So here we have, so this is 1 3 7 and 9. Okay, and here we have 2, then let's say 4 10 and 12. Okay, so this is L, this is R, and now what we are going to do, so this is L, this is R, and we are going to follow the algorithm. So this is I is here, so this index is 1 2 3 4. Here also the index is 1 2 3 and 4. So now what happens, and j is also at the index 1 of the R array, and I is at the index 1 of the left array, and we have an array A which has 8 elements. Okay, so now what we do is that we have I is equal to 1, j is equal to 1, and for k is equal to L to R. So what we do, if L of I is less than L of j, okay, so that is true here. So what we do, we have A of k is equal to, which is A of 1 is equal to 1 here. So we copy, so we have to fill the array A here, which has got 8 elements. So 1 2 3 4 5 6 7 and 8. So what we do here is, so here what happens, 1 is less than 2, so I copy it here in A of 1 and it becomes 1. Okay, so what happens, then we increment I and it comes here. Okay, so now what happens again, and k is now 2. So now we compare a L of I with L of j, and 3 is now not, it's greater than 2. So a R of j is less than L of I, so we copy R of j in A of 2. So here it comes 2, and j is incremented. So j comes here. Now for a of 3, again we compare these two and put the minimum here. So L of 2 is 3 and R of 2 is 4. So we copy 3 here, and now I is incremented and it is 3. Again and K is now 4. Okay. So we now compare 7, which is L of 3, with R of 2, because J is 2 now. So 7 and 4, minimum is 4, so it is copied here and J is incremented to be 3. Again K now becomes 5 and we compare 7 with 10, so 7 gets copied here and it becomes I comes to be 4. Now we compare L of 4, which is 9, with R of 3. So now 9 is again less than 10, so 9 comes here. Now what happens again? So this one we also saw there was infinity at these places, because there was one greater, we had an L and R where last element was infinity. So now what happens? We just have infinity here, so everything rests. So A of 3 is now compared with A of 5, L of 5, R of 3 is compared with L of 5, it's infinity, so it's copied here. So 10 gets copied here, J is incremented, it comes here, and now R of 4 is also less than L of 5, which is infinity, so 12 is copied here. Okay, so this way we saw that okay, in theta of n time we can merge two sorted arrays. Okay, so this is done. So next our work is, so this merge is done, so we can merge two sorted arrays in theta of n time. Next what is there? We want to analyze the merge sort. Okay, so if I want to try the merge sort algorithm here on this array, so what happens? Initially I will call merge sort A 1, 8. MS I will represent as merge sort and not MS Dhoni. Okay, so MS, so A 1, 8, and then what happens is, so this in turn will again, it will go there, and if we see the code here, so the merge sort is, it will call merge sort again A P, Q, merge sort A Q plus 1, R, then merge these two. Okay, so if we see here, so A 1, 8 it calls, then again here it sees that okay, now L is less than R, so again MS A 1, 4 is called, this in turn will call MS A 1, 4, the mid element is 1 plus 4 by 2, so it will be 5 by 2, and floor of that is 2.5, floor is 2, so A 1, 2 is called, MS A 3, 4 is called. Now what happens again, this L is this, R is this, so L is less than R now also, so it is called again, and Q, the middle point is 1 plus 2 by 2, which is 3 by 2, and floor is 1, so MS 1, 1, here MS 2, 2. So this way we see that we have the recursive calls happening for the merge sort algorithm. We saw here, so this is 1 plus 8 by 2, which is 4, so Q is 4, so MS A 5, 8 is called. So this way now how the merge sort works is, if we see here, so let's see, so we have these elements, so here it will be from 12, 21, 6, 16, and then what happens, it will again, now it will be 12, 21, and here it will be 6, 16, now it will become 12, 21, and this is 6, 16. Now we see that okay, this is the base case, now the problem is of size 1 and it is already sorted. So now we have to merge these two arrays using the merge algorithm. So we see that okay, if you merge these two, so it will be 12, 21 as such here, this is 6, 16, if we merge them, these two are sorted arrays of size 1, so if we merge them it will be 6, 16. So now these are two sorted arrays. Again what happens, if we have like this, so we have a pointer here and a pointer here, so 6 is copied here and the pointer moves to this place. Now 12 is less than 16, so 12 comes here and pointer moves here, so 21 and 16, 16 is less and then 21. So this is the sorted array of first the right part, and in the left part it is 3, 15, 18, 8. So now it becomes here 3, 15 and okay, so here it becomes, so okay, so here it is 3, 15, 18, 8, and here it becomes 3, 15 and 18 and 8. So here it goes 3, 15, 18 and 8. So now what happens is 18 and 8 when they are merged, so it becomes 8 and 18. This becomes 3 and 15. Now when we merge this, so 3 is here, 3 is less than 8, so 3 is copied here, it goes to 15. Now 15 and 8, 8 is minimum, 8 comes here, and 15 and 18, 15 is minimum, so it gets here and then 18. So we have now two sorted arrays of size 4. Okay, again we merge them. So if you see here, so we have pointers here right now, 3 and 6. 3 is smaller, it is copied, the pointer moves here, and 8 and 6, 6 is smaller, 6 comes here, the pointer moves here to 12. So 8 and 12, 8 is smaller, 8 comes here, the pointer moves to this point. 15 and 12, 12 is smaller, so copied and pointer moves to this. So 15 and 16, 15 is smaller, pointer moves here. 18 and 16, 16 is smaller, copied and pointer moves here. 18 is now smaller, so there was infinity here and infinity, so now 21 is copied. Okay, so this way you see we have performed merge sort operation. And now just let's analyze this algorithm. So this is analysis wise, its Tn is twice Tn by 2 because we are calling the same function merge sort but with half number of arguments, so it becomes 2 Tn by 2 plus Cn because it's the merge is theta n running time complexity algorithm. So now if we solve it, so by substitution method it's 2 Tn by 2 plus Cn, then Tn by 2 can be written as 2 Tn by 4 plus Cn by 2, and if we see, so it's 2 square Tn by 2 square plus C, this 2 and 2 gets cancelled, so Cn plus n. Now it becomes 2 square, and then Tn by 2 square is twice Tn by 2 cube plus Cn square, Cn by 2 square. Okay, so we keep on like this going, so it is becoming Tn is 2 cube, Tn by 2 cube plus 3 Cn. General form will become Tn is 2 to the power of I, Tn by 2 to the power of I plus ICN. Okay, if we keep on going like this and assume that okay n is 2 to the power of k without loss of generality, so it becomes 2 to the power of k, so n will finally becomes t of n by 2 to the power of I will become 1 when n is 2 to the power of k. So this is how we write here, and I becomes k Cn. So this is now k is basically log of n. So we see that this is nt1 plus Cn log n. So this is theta of n log n algorithm. Okay, so as it is known, merge sort. So merge sort is theta of n log of n.